lifelong student, and remaining as a student is an excellent experience. After we have implemented NEP 2020, I hope you can see the first slide, right? In which the details have been mentioned in Hindi as well, right? I encourage and request all the participants to prepare their signatures, email signatures also in this kind of Hindi language, right? Many friends are from Gujarat government engineering colleges, right? They can also write down, right? In fact, they can write down in Gujarati as well, right? So considering the mixed mass of participant, I have considered writing in Hindi. Otherwise, you can write down your domain, your details in Gujarati as well. That we strongly encourage. The contents of this control systems, sensor technology, AICTE, ATAL, FDP are very, very interesting. I must congratulate the coordinators for designing such a high quality faculty development program. Probably very rarely you will find a faculty development program which discusses and requests the participants to write down the summary of journal paper. We in the state of Gujarat, most of the time we are lacking, we are very good in teaching, excellent in teaching. But as far as research is concerned, publications are concerned, we have many limitations, right? So this particular initiative by the coordinators will definitely boost that particular lacking area amongst us. In today's session, we will begin with the introductory part of smart grid and associated technologies. We will also see the smart grid architecture, various instrumentation aspects from smart grid, telemetry systems among smart grid, which is the main topic. Then what are the communication technologies which are used for developing the telemetry systems in smart grid? Recent trends like IoT and AI integration in smart grid instrumentation telemetry, along with the application details that will be discussed, along with some case studies. We will also identify certain challenges and possible resolutions, and then we will conclude this session. I would appreciate if the participants ask any kind of questions by interrupting me. That would be highly appreciable, right? Instead of keeping the Q&A, formal Q&A at the end, that would be highly appreciated, because that brings a lot of interest among the participants, right? So please ask any questions, any kind of question, right? Even if you find it very, very simple one to answer, correct? This is a multidisciplinary profile of the participants. So keeping that particular thing in mind, I have tried to curate my presentation, which can be very simple and understandable by all types of participants coming from various disciplines. Smart grid. Before we discuss, let me give you one small example. Suppose I don't like, or I am not feeling happy with the services of my mobile telephony provider XYZ. Let us not name the company, but I am not happy with the services. What do? I change it, right? And for changing that, we have one special facility available by the government, and that is called portability. Keeping my number same, I can change the service provider, right? Similarly, so without hampering my database electronically, where my number is stored at many places, including income tax and all those things, right? Without changing those database, updating those database, I can change the service provider. But that facility is not available with electrical supply. Smart grid brings that change. That particular feature is now enabled by implementation of smart grid. Many things you will we will discuss about this, right? But among them, the prominent feature is this, that the user, consumer, will have an opportunity, will have the right to choose the utility supplier, electricity supplier. Many times it happens that I am operating a factory in Bardoli, I am operating a factory in Hazira, a big plant, right? but I don't have the electrical supply available to run my factory because there is a power cut. I am ready to pay higher prices of units, but the utility supplier is not supplying me, he is not ready to supply because there is a power cut, scheduled power cut. We cannot be an exception, right? It is quite possible that in some parts of Gujarat, the power is available. Like nearby Dwarika, Suzlon is operating some windmills, or Vestas is operating some windmills, and the power is available. But then there are no users. In Charanka, the government power plant is available with lot of unused power produced by the solar PV cells, right? One of the biggest solar power plant in Gujarat, right? But there are no consumers. There is a consumer and no availability of electricity. There is an availability of electricity and there is no consumer. Unfortunately, we don't have a setup where we can store huge amount of power, right? That much size of capacitors or capacitor banks we don't have. So what we do, we produce only that much which is required by the consumers, and we try to meet the consumers in the instantaneous demand. Now that means that establishes a lot of unbalances in the electricity production and power supply availability to the consumer. So consumers are always dissatisfied that I am ready to pay, but the utility company is not providing power. In many places the power is there but it is not used, right? Smart grid is providing that solution. The present grid is not a smart grid. It does not have that smartness, right? It is a manually operated grid, right? So in a manually operated grid, they just provide the load balancing, right? They are struggling to provide load balancing. If we go into detail of this, many times we are operating the power plants on different types of fuel or different types of concepts like wind-based power plant, solar-based power plant, thermal power stations, right? Now in thermal power station, coal is the prime mover. If we don't have coal, how can we run the power plant? More than 60% of the power plants in India today, even today, right, are coal-based. And you know very well that we are running a scarcity of coal. Now, if I want to serve you something, right, I have to bring it the raw material from outside India and run a power plant here. That is a very costly business compared to the cost of the coal, right? Cost of transportation is such a high. Like many power plants are run by bringing the coal all the way from Australia, right? So this particular thing has resulted into situation, right? And then we add up the spice by offering free electricity. That's a political gimmick, right? So the power business, energy business is running into huge losses. Unfortunately, most of the private power suppliers, they are not ready to enter into this business at a large scale. Those who are running, they keep on running, but they don't want to expand because of this kind of limitations, right? Smart grid provides a solution of these limitations, right? So if I am operating in Bardoli, I want to operate my sugar mill, there is a power cut, I can select the power available by Tata Power in Mundra or Adani Power in Mundra or Tata Power or Torrent Power in Surat, right? And I can use that electricity right here. So instead of one meter, you will have a smart meter with many displays, right? That will bring out a lot of efficient use of power production and the distribution facilities. This is smart grid, right? The grid is smart. Now the grid is able to provide you options that Torrent Power in Surat is able to give you the offer. For example, large number, more than one suppliers are ready. Then the cost would be the factor of decision making, right? So for example, Torrent Power Surat is offering you the unit charge, 1 unit at the cost of 5 rupees. At the same time, Dakshin Gujarat Wijj Company Limited is able to give you the same amount of power at 4 rupees. Now you have an option, right? At the same time, Charanka is offering you at 3 rupees because it is solar based. So now you have an option. So efficient use of power, right, and distribution of power is at the core of smart grid. The grid is now becoming smart. user will have the option what to choose, when to choose. Not only that, you can schedule your power supply that during daytime, this much time, I will use power from this company at this rate, right? And during this peak hours or off peak hours, my power will be available from this company. So optimization will take place in case of power consumption or power usage. This is the best benefit of smart grid. Correct? Now, another benefit is integration of renewables. Nowadays, large number of residential premises, they have solar rooftops, right? So now you are not a consumer only, you are a producer also. So there is a new term coined under the domain of smart grid, that is called prosumer. We all are now prosumers. Producer plus consumer, it is prosumer. So, a modernized electrical grid that uses digital communication technology to enhance efficiency, reliability and sustainability. The solution which we provide should be sustainable. Smart grid is a sustainable solution. I will also tell you in India what are the developments related to smart grid. We are going in a very large way. Already we have progressed quite a bit, right, as far as smart grid is concerned. That we shall discuss. I will also share with you what my research remaining regarding smart grid is. Right? As defined by AICTE 2011 standard, a smart grid is an electricity network that can intelligently integrate actions of all users connected to it. There are many stakeholders or users. Right? It could be generators, means power producing companies, consumers, distributors, and all. To deliver sustainable, economic and secure electricity supply efficiently. Right? We are running with a lot of power losses. So smart grid will try to minimize those power losses. It's a great solution, right? That will result into energy backbone of smart city. I have got one chapter which I request you to read, published by Springer in a Springer published book, Springer Nature. Right? Smart grid and energy backbone of smart city. Without implementing smart grid, smart city cannot be realized. If you want to make your city smart, right? First of all, the grid, that is an electrical backbone, electricity backbone, power supply backbone must be smart. If that is not smart, none of the smart city applications can have power whenever they want. And without electricity, your smartness of the city cannot be realized, right? So smart grid must be there before realization of smart city. It's an energy backbone. It is a cyber physical system, right? That and its reliability depends upon reliability of communication. Communication is the one of the key aspect of the smart grid, key enabler of the smart grid. And instrumentation plays a very vital role here. The smart grid communication is modeled as instrumentation telemetry system. Now, what is telemetry? Tele is a word which indicates remote. Right? Tele means remote. Telephone, like remotely talking. Right? Tele and metry. Metry is associated with metering. Right? Metering means recording. Right? So remotely recording. Right? Anything I want to record, I can record remotely. But I can record something, some parameters, some phenomena, voltage, current, power factor, etc., etc. Right? Only when I measure it. No measurement, no recording. Right? So first of all, measurement. And to measure something, I must have sensors, right? Which will access that data. Right? So remote access, remote measurement, remote sensing, and then remote recording. This ultimately results into remote control. This is a remote control, a small application of remote control. Right from that, power plant control, remote. Right? You don't need to be in the control room of the power plant. Using communications, right? You can access your power plant control room from anywhere in the world. Like Jamnagar Reliance Refinery. I am working from many years for the placement, and I am very happy to share with you Then previously during last 8 years ago approximately 2016, I have been given this responsibility to take care of placement. At that point of time it was 32% placement, right? I'm very happy to tell with you in the last convocation the batch has passed with 100% placement. That too incorporating the effect of COVID. You might have been aware, because most of you might not be from computer IT branches, so placements have been severely affected. Believe me, it is having direct connection with admissions. No placement, no admissions. So we provided a special focus on placement. That too placements of diploma to degree students and female students. Normally instrumentation is considered male dominated branches in which the plant kind of jobs, right, process jobs, shift duties are encountered, and big process plants are like Reliance or ONGC or DCM Shriram, Honeywell, Emerson. They offer jobs where normally the female candidates are not preferred for that jobs. But that is why the average strength in my classes used to be 4 or maximum 6. Last batch which passed out with 100% placement had 15 female students. Record 15 female students, and all are placed. Right? We could bring a transformative change in the placement, and that has attracted the admissions. Right? One batch has got a problem of admission. Right? Slightly low admissions we have faced immediately after COVID lockdown, where it eased out. Right? After that, our admissions are flourishing. Right? My institute operates with mixed kind of setup where government admissions and self-financing admissions both are there. Right? I am sharing with you openly this key of solving the problem of admissions. You will definitely get flourish of admission without publicity. See, you will never find in any social media, in my personal media or my students' media or my university's portal, that the things are highlighted, or we are not marketing. We provide zero budget for marketing. Our publicity budget is zero. Right? We believe that, our vice chancellor says that let the work speak for itself. Right? We carried out placement immediately by mouth publicity, personal publicity, admissions are flourishing. None of the seat is available. Right? That is the success. So professors are nowadays expected to provide real life problem solutions rather than teaching. And most of the areas where the problems are there, right? We as a part of teaching community, we need to study those problems. Many times during these days we have the internships. Students are deputed for internships into various companies. Right? Government has also supported immensely for providing internship, and government is having that scholarship portal also, internship portal also. Right? Government is giving a lot of support. What we can do, that we can smartly request our students to study long pending industrial problems whenever they approach the industry. We operate on a model in which 2 times a student is given industrial exposure. First in the 6th semester, I'm talking about degree engineering, 6th semester summer internship, right? That will take place very soon in the month of May, right? That is a 4 to 6 weeks internship, compulsory. Everybody has to go, right? And second is full 8th semester, full semester, right? So in the first 6th semester summer internship, we request our student to go and search for some pending problems in the industry. Whenever the industry is operating, they don't have enough time and opportunity to study the problems, right? And they are just focused upon how to carry out the production, how to run the show. In that course of action, many problems, smaller or larger scale, till the plant is working, they keep going, right? Their pressure is different. That is a production target, right? That is why in industry, even if you get surprised, in Reliance kind of company also, in ONGC also, there are large pending problems, right? Those problems we can bring. we can bring among, we can not only bring and tap, we can discuss among the researchers, professors, students who are already working there, right, with an alumni network. Try to formulate a problem, try to formulate a solution, and that can be implemented when they go for the final semester, 8 semester internship, semester long internship, and you can get it solved. On those kind of things we can publish papers also. So it is a win-win situation for students, for professors or researchers. We can meet our publication targets, right? And those kind of problems cannot be addressed without active involvement of a professor with a company, right? So everything would be a win-win situation. This is an interesting thing, and that will bring out a lot of placement also. So if you can solve a small problem of the company, right, definitely that company will have a lot of positive feeling about you, your institute and your students, and that will result into good placement. Good placement again transforms itself into good admissions. So all problems can be solved by this particular kind of a setup. Coming back to this, the smart grid is an imaging area where we can work upon, right? And lot of things have been carried out by the present government in the area of smart grid. In every state and union territory there is a smart grid pilot that they have implemented, tested and completed. And now they are running with implementation of smart grid in different cities, right? So there we can join as a researcher, as a professor, we can contribute certain things, right, depending upon areas of interest. That will generate lot of publication avenues, papers and employment for our students. In fact, that can also result, if you are interested, that can also result into revenue generation of consultancy, right? Smart grid has some key features: real-time monitoring and automation, right? Now that is an interesting aspect. Smart grid is an electrical grid which carry out self-diagnostic and self-healing, right? When we fall ill, we go to some doctor, right? And the doctor will prescribe us some tests. Kya ye test kara ke lao, wo test kara ke lao, and based on the test reports, they diagnose that probably, right? Not very sure, but probably you may have this problem, and they will prescribe you some medicine. You can get medicine, and then if there is a grace from God, you can get healed yourself. Otherwise, they will prescribe some other test. So it's a trial and error kind of solution, right? But what about if we go for a periodic health checkup, right? And we diagnose that after checkup, I'm having a development of this kind of small problem, right? So at the beginning level, the problem can be taught, can be detected, and the solution can be provided. So the problem doesn't become a big issue. Before that, its solution is provided. Smart grid is an intelligent grid which diagnoses its own health, self-diagnosed, and it also has the facility to self-healing. It can heal itself. It will report the problem. मेरे में ये problem है, मैंने diagnose किया है और solution भी कर दिया. Just for your information, I am giving this report. Right? If you need some hardware issue, software issue, or those kind of issue which it cannot automatically solve, then your user intervention will be required. Otherwise, no. So smart grid's best feature, to my understanding, is self-healing and dynamic real-time responses to power disturbances. I hope you remember during the COVID period, once upon a time, we had a total country going for a blackout for some 5-10 minutes. Right? That was announced by Honorable Prime Minister. Right? And then we again turned on all the electrical appliances, except hospitals and those crucial locations. The entire country went into dark. And again after that, we started using. Now those friends who are from electrical engineering, they understand how big this task is. It is not that easy to switch off and switch on something, right? Because whenever a grid is losing consumption, load is thrown, right? Suddenly the grid is available with large amount of unconsuming power. Huge amount of power is available. उसका क्या करना है? Because we don't have storage. And then after 5-10 minutes, suddenly the load is joining the grid, right? And the grid, there is a quite possibility that grid may go unbalanced or grid may collapse. right? So that was not an easy exercise, but we could do it. The power minister himself was sitting in the NTPC control room. If you have seen that scene, that was a very fantastic kind of experience. That has brought out what is our resilience in our power system. Right? Many times we curse our system. India માં સારું નથી, India માં ઠેકાણું નથી, ભારતમાં આમ નથી, બરાબર નથી, પેલું નથી, right? But we have tested our resilience in that simple single incident, and we have become successful also. I don't think this kind of incident has taken place in anywhere in the world. Correct? So अगर ये होता भी, suppose collapse हो जाता, तो भी problem नहीं था. Not a single collapse in none of the states, none of the union territories, entire India. It was a great miracle. As far as engineering is concerned, it was a great miracle. Just like Chandrayaan, right? But people have not understood this well. Those who are from electrical discipline or associated discipline, they can understand this was a very big thing, right? Because suddenly you are throwing the load of the entire country for few minutes, and suddenly the country joins, right? The grid cannot be balanced. If you are working in a control room, right? Now in the 7th Pay Commission, the government has made mandatory for industrial training. Right? I am a member of the CES committee as well, of DD. So I have studied the government resolution GRs. So it is important to work in the industry for 15 days or so. Correct? So if you work in a control room of an electricity company, you will understand that the load balancing, load matching is a very tricky issue. And if you do it on the entire scale of the country, it's a tremendously great exercise. Right? So, in fact, we should clap for the people who are involved and who did this. So, smart grid is that grid that it will respond dynamically to the real-time disturbances. Many times there are collapses because of the natural calamities, because of certain kind of technical issues, certain kind of issues which are based on weather changes or climatic conditions. Right? Smart grid will automatically respond to those kind of disturbances and the self-healing capability. Now, one more problem is how to integrate the renewables. Those who are knowing about solar PV operation and solar PV integration, they know very well that solar PV is generating DC supply. So we have to keep 2 meters. 1 meter as far as rooftop is concerned, right? 1 meter for generation and 1 meter for consumption, because we are consuming AC and we are generating DC. How to supply the whatever we have produced to the grid, and how to keep a record of that, and based on that we are getting the credit, right, in power purchase agreement. So solar, when the electricity is generated, which is not in the same format to which the present electricity company or current electricity company is generating, right? Then to integrate that in the same grid, that is online integration, is very difficult. Large number of research papers have been published in this area, right? How to integrate renewables. इतना सिंपल नहीं है, एक पंखा चला दिया, right? You generate a power through windmill, right? You can use it offline in your farm, in your factory, right? In your residential consumption, right? After converting from DC to AC. But when it comes to supplied online on the same grid from which you are consuming the power, it is a very complicated issue, because you have to match the voltage, frequency, power factor, and many other things. And if the power collision takes place on the same grid, right, the entire grid may collapse. So a smart grid is able to provide you solutions for real-time integration of those kind of problems, right? Now, after availability of EVs are very popular, right? But many of you might not be, observing or studying EVs as dynamic power sources. In foreign countries, they use EV as a source of power which is dynamically available. For example, normally what we do, we run the car by charging it through the charging station. That's all. That is what we do with the EV, right? In foreign countries where smart grid is there, they take the power back from the EV and supply to the location where there is an urgent need. So EV is something like moving capacitor, right? Moving battery or power bank, right? In power bank we take it after charging it somewhere wherever we need, and we connect our mobile or laptop with the power bank and we use it, right? Something like that. So EV is when it is fully charged. If you are not running the EV can also be used as a dynamically moving capacitor or a power bank, right? And we can take that power back in the grid. So large number of EVs, when they are connected for charging, they are acting as a load. Same number of EVs when there is no supply on the grid. Suppose in the entire society, right, all the members of the society or apartment, they are using EV, right? So there are 100 EVs available, fully charged. And due to some problem, electrical issue, technical issue, the power has got cut, phase has got cut, or one particular line has got cut, feeder got cut. So you are very much sure that for 5 hours, 10 hours, you are not going to get the electricity. It is isolated. It is called islanding. You are islanded, right? So आप आगे टापू पे और उसके ऊपर कुछ नहीं है, right? You can collect your EV and send that power back in the local grid, right? Which is called microgrid, right? And you can use that power till that regular power resumes, right? So this is another thing which India, it is in the trial phase. So integration of renewable energy resources, it includes EV also. Many other such things are going to happen. Enhanced consumer participation. Now this has already been taken place at all the smart grid pilots. In Gujarat, anybody knows where is the smart grid pilot in Gujarat? In Naroda. In Ahmedabad, in Naroda, smart grid pilot has been conducted. Right? Now, choice of the location of conducting smart grid pilot is also very important. Naroda is nearby the airport. Naroda is nearby the Naroda GIDC. Naroda is having lot of residents. So residential, commercial, industrial, all types of power consumers are there in Naroda. So its customer profile is quite vivid, and based on that, Naroda has been selected. UGVCL has conducted this smart grid pilot, and the results are very, very interesting, very, very fabulous. Okay, so in smart grid pilot, the consumers are participating in consumer satisfaction survey. That smart grid has been implemented. Yes, sir.
What is the function of smart grid pilot?
That I'm telling you. Smart grid includes 19 different applications, which I will try to cover in this presentation itself. Right? Many of them have been implemented in a pilot. So pilot is a small version, baby version of the entire smart grid, and then they test. After testing and based on the consumer survey, consumer satisfaction survey, based on the company which is conducting the pilot, they go ahead. For example, in IIT Kanpur, I believe, right? They have implemented a microgrid solution as well. So in each state, they have got many different pilots, where out of these 19 applications, some applications are implemented and tested, and after that they are going ahead with expanding the capabilities of that each pilot. So for example, in Naroda they have tested AMI, automated metering infrastructure, right? So there are different 19 applications which I will discuss with you, and in a pilot, once they test and they found that it is satisfactory, the results are getting satisfactory, they add more applications. So phase wise implementation of different applications are taking place. AMI and DSM, these are the two prominent applications, demand supply matching. Okay, AMI is automated metering infrastructure. Now nobody will come to your premises to read the meter reading, right? They read remotely. Okay, both. I mean the supply side meter, that is generation meter, as well as consumption meter. Improved fault detection and response. Anybody from Ahmedabad or Gandhinagar or Surat? In Ahmedabad or Surat, where torrent supply is available, right? You would wonder that whenever there is a probability of electricity supply deduction, I mean supply failure, right? They send an SMS that during this time the power supply may not be available because of the technical fault, and it will be available by this much time, and normally before the scheduled time the power is resumed. So power supply failure in Ahmedabad or Surat, right, is a news, and it is a rare incident. I am working in Nadia, where MGVCL is supplying power. It is a routine thing. I mean, when I am speaking this, right, anytime the power can vanish, anytime can resume back. Nobody can tell you, right? And whenever we have the functions like convocation or orientation program, it is a big issue to maintain the event, because if there is no power, nothing will run, right? So that much load you cannot transfer on the generator, even if you have that kind of. We have a multimedia hall of more than 600 seating capacity, right? Like a multi-story this, right? So you cannot operate that scale using your generator. So reliability of the power is very high, correct? So demand side management will tell you the actual use of the power, the power consumption profile, and it will also help you if you implement AI on this, that this is the data of power fluctuation, power consumption, right? And based on that you can make the prediction that during that particular time, for example, we are in February, in the March, in the April, right? After Mahashivratri, normally the winter season ends, right? So normally I am going to have a rise in the electricity consumption post Mahashivratri, right? And then it will peak out in May, right? So that power, and in which particular area what power consumption is taking place in industrial area. So your power company will more intelligently plan not only the power production, but that raw material supply in terms of coal, in terms of other materials as well. So it helps you in optimizing the schedules, production planning and schedule as well. Now there are four major aspects or the sub-domains which are called components in smart grid architecture. First is generation, traditional and renewable energy resources which are a part of generation. Second is transmission, high voltage transmission lines and substations which avail power to your doorstep. Third is distribution, smart meters, smart sensors and grid automation. And fourth and most importantly is consumption, consumers, where we are there, right? So smart homes, electrical vehicles and demand response systems. In some places, for example, let's say election has been announced. Okay, now election is a big event, right? Lok Sabha election, Vidhan Sabha election is a big event. Now at different places they are going to organize rallies and then Sampark Yatra, Sabha, etc., etc. If you see from an electrical engineer perspective, right, the power consumption suddenly spikes up into that area. And after that rally is over, that event is over, suddenly it comes down. It is quite possible that the distribution network is not able to handle that. Right? I told my carpenter, I called him for some work, and most of you might be having similar experience, that they come with kind of a cutter with 3-pin plug but having a 2-pin, and none of the pin is available, only 2 wires. Right? They cut earth, right? And then it is a 15 ampere cutter, right? And then they connect it to 5 ampere plug. As soon as they switch it on, right, my MCB trips. So what is his first response? Sahib, તમારું supply બરાબર નથી, તમારે ત્યાં અર્થિંગ નથી, તમારે ત્યાં સપ્લાય લાઈન બરાબર નથી, આ બગડી ગયું છે, આ ચેન્જ કરાવો. પછી મેં એને કીધું ભાઈ કૂવામાં ના હોય તો હવાડામાં કેવી રીતે આવે? 15 એમ્પિયરનું સાધન તમે લગાવો છો, રાઈટ, અને 5 એમ્પિયરનું સોકેટ છે, રાઈટ. Some fellows are very advanced fellows, right? What they say, sir, I am using an extension board, right? In extension board I am having a 15 MVA plug, right? Socket, right? And I am connecting in 15 MVA. But that extension board is connected to 5 volt. I said, भाई आ extension board जे power supply generator नहीं, right? This is commonly seen incident in our residential premises. आपने बोला ही है जो मानस ने. See, privately speaking, we are professors, right? Many of us are PhD. जो તમારે ત્યાં પ્રોબ્લેમ હોય તો તમે માણસને બોલાવો જ નહીં, જાતે સોલ્વ કરો, પ્રોબ્લેમ સોલ્વ કરવા પ્રયત્ન કરો. હમણાં જ 2 દિવસ પહેલાં જ મારા ઘરે actually I was in Motera to see that match, right? So my daughter was at home. She told me, Papa, light is on. Okay, you call me on a video call, right? I have seen the situation, right? And then as soon as I was returning back from Motera to my home at Satellite, right? I did certain things to resume it back. Please use your knowledge in your laboratory, in your residential premises, wherever it is possible. Taste it, verify it. It is very simple thing. This is what I have learned from my guides or gurus at IIT or PDPU. You know, fortunately I had very high quality guides. This is what I have learned, right? कि आपने टेस्ट करવો જ જોઈએ. The most of the problems are started when we don't use our knowledge in the domain, right? Only keep it limited to lectures and laboratories or exams. That's it. Please use it in this. See, similarly, I am a member of SSIP Evaluation Committee in Sector 28, Gandhinagar Government Engineering College, right? So, large number of funds government is giving for SSIP project. Many of you might be aware of this. May be involved also as a mentor, right? But frankly speaking, we rarely use our own concept or knowledge. We don't take that much attention. ये करो ना, right? You will get lot of benefits out of that, technical benefits out of that. Large number of professors have been appointed as independent director in many companies in Gujarat, in institutes like you and me, where we are working, right? So we can also work. This is also one of the form of revenue generation, right? Consultancy or revenue generation. But that can happen only when we test our knowledge periodically with the industrial problems, right? Many times I also make mistake. Nothing wrong in that. But that is how we learn. If we don't take that initiative or put that foot forward, we are not going to learn, right? And always try to work on something which is very, very recent kind of thing, latest updates, right? For example, hydrogen fuel cell technology. Singapore has tried much, right? They could not implement. But our Mukesh Bhai Ambani is trying very hard, and I am very faithful that they are going to get success. It's a costly technology, it's a risky technology also, hydrogen fuel cell, right? But whenever you have an ambition, you have the enthusiasm, that will keep you driving to implement the oxygen supply plant, clinically grade oxygen supply plant. It takes minimum 6 to 8 months, right? During COVID period, Reliance Jamnagar has converted their industrial oxygen generation plant into clinically graded plant and supplied large number of tons of oxygen, right? Within 15 days. Our students are working. Even my own, more than 80 students are working. Instrument engineers are working in Reliance Jamnagar. They shared this experience with me. It's a miraculous experience. Okay. Industrial grade oxygen producing the feedback received by the sensory organs, right? All indriyas, right? And the hands, foot, these are our control elements, right? So I want to walk from this place to this up to this, right? Brain will decide and send a command to my limbs, to my legs कि आपको चलना है, इस डायरेक्शन में चलना है, ये काम करना है, वो काम करना है. But from brain, that signal travels electrically. There is an electrical pulses. If you are aware about biomedical instrumentation, it is electrical pulses, right? And pulses are generated, and through electrical pulses traveling through our veins, those body parts are activated, which are to be used, right? And this process is so fast, so rapid, that we don't realize how fast this communication is taking place inside our body. For example, this object is very, very hot, and somehow I got a touch of it. Immediately I will withdraw back. See, what is the time to measure or sense? What is the time to send that signal to the brain? Is a controller, and that controller has already taken action, and that action is also sent to the organ, and it is withdrawn back. Super fast, rapid speed of communication. It is so live that we don't even realize कि ये हो भी गया, and it becomes a routine part of our life. But when somebody got paralyzed, then you will understand the real power of the communication, right, of the body. That his body or her body is not responding to the command sent by the brain. So whatever features we envisage using smart grid, right, if there is no communication between the main controlling body and the acting enablers, right, then the smart grid cannot work at all. It is as good as paralyzed body. So role of communication network is very, very prominent in the smart grid. It enables data transfer, remote monitoring, remote control, and automation of entire power infrastructure. And this is the smart grid conceptual model, right, developed by NIST US, right. It incorporates all the stakeholders, and their integration takes place. Meaningful, useful, and timely integration takes place in an efficient manner by communication network. This communication network is not of only one type. It is a mixed mode communication. Somewhere it is wired, somewhere it is wireless. Different protocols are used, right? And based on the need, the communication solutions are provided. For example, markets. Many of you might be aware about IEX. It's a company. It's an exchange where power is traded. Suppose West Bengal is in need of power, or Assam is in need of power. Most of the time Gujarat is in surplus power, right? We are a regular supplier to Tamil Nadu, if you are knowing, right? So Tamil Nadu, whenever they buy power, they put up a request on IEX that I want this much gigawatt power from this date to this date, right? Those who are having availability of power, extra power, or ability to provide that power, they quote. And those who are having, whomsoever is L1, they get the offer, right? So based on that, that power is transferred from Gujarat to Tamil Nadu. So in Gujarat, from Gujarat state grid, the power will flow to the western grid, from western grid to central grid to southern grid, and southern grid to Tamil Nadu state grid, and then to the location. Right? Now, how the power is guided on this grid? Grid is not having any intelligence. Present grid is not having any intelligence. When the present grid is combining the power of communication, then the power is guided. बीच में से कोई suppose महाराष्ट्र लेके यूज कर लिया तो कौन करेगा? तमिलनाडु बोले कि हमारे पास पहुंचा ही नहीं, हमें तो मिल ही रहा है. We already paid the advance payment, right? So that is not happening. Even Bhutan, we are regularly supplying power to Bhutan, to countries like Bangladesh, right? Nepal, you know. So wherever there is a market, wherever there are the customers, right? They put up the order on the market. From the market, the utility generation companies, right, including distributed energy resources, that includes renewables also, they take the order, they generate the power, right, and send it to distribution domain. Distribution domain with help of transmission domain, they supply to the customer. Here, the role of communication is in each domain, right? Secure communication lines are required. So as a part of smart grid, there are 4 types of infrastructure. First is physical infrastructure, that includes energy, water, waste, transportation, buildings, markets, right? City command center, control center, right? Many of you might be knowing MDC, Jammu and Gujarat level load dispatch center, right? So that is called command center. Second is institutional infrastructure, that includes governance, transparency, accountability, security, emergency services, enforcement. See, this institutional infrastructure sets up the guidelines, rules and regulations, frameworks, how different businesses will take place. How different stakeholders will interact with each other. For example, PPA, Power Purchase Agreement, right? So solar power policy, those kind of guidelines and frameworks are prepared like. Similarly, social infrastructure in terms of health, education, right, innovation, and people's participation. And the last but not least is economic infrastructure, economic and finance. These are the four major subsystems. Key components of smart grid instrumentation involves sensors, which are voltage, current, temperature, power factor, etc. Right? PLUs are also implemented. Right? Transducers and actuators, which works as a field devices, and the data loggers and data acquisition systems. These are smart instruments based on microprocessor and high-speed communication facilities. They acquire real-time data. Right? Here, the weather is also playing a very key role. For example, in Ladakh, we want to implement a power station. Which type of power station you would implement? Wind, solar, thermal, hydro, tidal. Difficult. We cannot say we will not supply power in Ladakh. So there are difficult areas, difficult terrains geographically, and in situations like Ladakh or Arunachal, where minus 35 degrees centigrade temperature is quite possible in many regions. Now, if you don't supply power, it's very difficult to handle the situations over there, right? So, just like education, now the access to electricity is also kind of fundamental right, right? So, those areas, the climatic conditions study is very important. Wide area situational awareness, right, in the large geographical area is to be studied, and that is carried out by PMUs. Right? PMUs are implemented, they carry out studying or measuring the ambient parameters, ambient temperature year round, ambient barometric pressure, ambient humidity. Right? If you have the power plant, let's say refinery is there in Vadodara, IOCL refinery. Refinery is also there in Jamnagar, right? And refinery is also there in Bhatinda, HPCL refinery, Jamnagar Reliance refinery, right? You can see that Vadodara, that is Koyali refinery, Jamnagar refinery, and Bhatinda refinery, the location is totally different. And hence, the ambient parameter, year-round ambient parameters are also extremely difficult. Totally different kind of profile you have, right? Don't you think in a process, complex process like refinery, you might need to study those ambient parametric variations because they impact your consumption of steam. In Jamnagar, year-round weather is quite humid because it is on seashore, but in India it is not a case. So, as an engineer, if you provide the same solution which you are providing in Bhatinda, right? If you are providing for the Jamnagar, it is not going to work. So there are two types of telemetries are preferred. Telemetry means communication between field and the control center. First is wire telemetry. Wire telemetry is implemented using optical fiber, power line communication. Then there are various Modbus protocols and RS-232 protocols are also there. Second is wireless telemetry. My research was focused on wireless telemetry solutions providing for smart grid applications, which includes RF, which includes satellite and cellular networks as well. Now, many of you might have came across this word SCADA, Supervisory Control and Data Acquisition System, right? I popularly, whenever I teach SCADA to my students, I give an example of exam conduction. In exam, whenever we are conducting exam, the students are writing answer scripts, right? We are having supervisors, junior supervisor and senior supervisor, right? Let us take a class like this where the students are writing the answers in the answer script, and there is a junior supervisor, right? What is the role of junior supervisor? He is a part of this system, but he is not writing any answer script. That means he is just observing that whatever set of guidelines, rules and regulations are followed. Number one. Number two, there should be proper material supply. Somebody needs graph paper, somebody needs extra supplementary, whatever, right? Threads, etc., staplers. All the material is available timely. इधर टाइम का बहुत इंपॉर्टेंट है, राइट? एग्जाम खत्म हो गया, उसके बाद आप सप्लीमेंट्री दोगे, उसका कोई मतलब नहीं, राइट? सो supervisor is a person in concept of SCADA. The same analogy is applied. Supervisor is a person who supervise the entire process and get the things done, but he does not or she does not take actual part in that. काम करने वाला कोई और है. So when we have a state-wide SCADA, Gujarat State SCADA, right, which is accessible through LDC Jabua, they are having data coming from all power producing companies or power plants, right, and then they switch the load, right, try to match the load wherever there is a scarcity and wherever there is an excess power. This business they are doing, correct? So they are, LDC Jambua is not producing any power, not a single unit of power, but they coordinate among the power producers. For example, there is some big event going to happen in Bardoli or Navsari or Surat, and SEC or the Dakshin Gujarat Wijh Company Limited is not having that power, that much power to handle that event, to supply, to fulfill that event requirement, right? LDC Jambua will call to Torrent, Ahmedabad, आपके पास power है, extra power हो सकता है, is it possible? They will call to UGVCL, they will call MGVCL, they will call Adani Power, they will call Tata Power, Reliance Power. So private and government, all power producing companies, they will coordinate. Whomsoever is having power and they are able to supply, put it on the grid, bring it here and satisfy the power demand. So LDC Jambua is a supervisor, and the power plants, power producing companies, their plants are the actual students who are working, right? So supervisory control means there are different controllers who are actually doing the control in the plant. The process is being controlled, and supervisor sits on them and sees that the efficient coordination among the controller takes place, correct? Now this work cannot be, obviously this work cannot be done via manual call or something, right? You should have a live data available. So suppose from Tata Power they have live data stream available that Tata Power is having this much amount of coal available and their production level is this much, right? And they can increase the production demand, production producing, right? So that is how live data availability is required, and that can be done only when you have the real-time data transfer using communication. So data acquisition, data transfer along with supervisory control. If you don't have real-time data transfer, right, available live data, we call it dashboard, right? If it is not available, the supervisor cannot take decision. Supervisor has to take decision, and this should be implemented on the actual power producing companies. For that, data is required. Yes, I told you about the 19 applications which are implemented in across the country in various states. Right? These are the 19 applications which are implemented as a part of smart grid, and there is a smart grid central control center. Correct? Yet to be realized, but the work has been already started by Power Grid company. Many of you might be knowing. Right? The first and foremost is advanced metering infrastructure, under which remote data acquisition for metering purpose takes place, billing also, right? Second is supervisory control data acquisition, that is SCADA. Third is meter data management system. Remotely, you want to upgrade the firmware of the meter. Remotely, you want to, just like we are updating apps through Google Play Store, right? So remotely, the data management system takes place. Whatever data is stored in the meter locally, that can also be fetched. Distributed energy resources and storage, right? Now storage includes PV also, EV also, right? And distributed energy resources, like somebody is having grid, somebody is having windmill, somebody is having solar PV, right? So it is distributed geographically, right? And their integration is the entire grid. Distributed grid management and demand response. Demand response is a very key feature. During some particular time of the day, the demand peaks out, right? And during that particular thing, the curve flattening, smoothing of the peak is required. Otherwise, there would be a lot of stress on the distribution network, which periodically cannot be handled. And so demand response is that key. Distribution automation, right? Power quality management. We are producing power, but if it is not of proper quality, then also it will not serve the purpose. कैसा भी power दे दोगे, right? The electrical components or electrical accessories or equipment health will be compromised. So power quality management is an essential one. Substation automation. In geographically distributed consumption, large number of substations are deployed. In every substation, some data is to be measured, some data is to be calculated, and that will give you a lot of insight when you are doing this data analytics, right? Forecasting. Distribution transformer monitoring. Distribution transformer is one of the key part of the entire grid, right? Most of the time the transformer fails, right? So to improve upon that transformer life, right, the remote monitoring and data analytics of transformer is also necessary. Home energy management. When you realize the smart grid in real sense, the home will transform itself into smart home, right, with digital devices. Those who are having Geo fibers, they might have seen some advertisement related to smart devices in home, right? So they have started with smart home concept, where with local Geo network enabled by the fiber or air fiber, right, you can integrate the home appliances, key home appliances like air conditioner, which can be remotely accessible even if you are not in the home, right? Which later on it may include CCTV and other features as well. So home energy management, right? For example, if I am outside my home, but my requirement is whenever I am reaching my home should have this much temperature. So my air conditioner should be started exactly, let's say half an hour prior to my reaching home, because Google Map is showing that how long will it take to reach my home based on live traffic now, right? So automatically the air conditioner will be started and it will make the temperature accordingly, right? This looks quite luxurious application, but the way heat waves are coming, probably air conditioners will become a part of our life rather than the luxurious item. Now it has become the essential item. Similarly, if you are operating farms, right, the irrigation is also a key problem, right? The farmers have to go during the night time for irrigation purpose, because they are getting electricity during night time only, right? So if we can schedule those things, right, lot of human comfort we can generate. Outage management. Suppose in spite of so much care has been taken, you lost the power. How do you manage that outage, right? Some years ago, Maharashtra had a very big tripping. Entire Maharashtra went into power cut. There was a problem related to their digital relay system, right? But Gujarat, being a part of the western grid, that problem was not faced in Gujarat, because we quickly isolated Gujarat using microprocessor based relays. The entire Gujarat was isolated, and that problem was not resulted into cascade tripping of Gujarat also. Otherwise, normally into those situations, right, it was because of the frequency problem. So in certain areas, the power plant has generated that particular frequency which was not matching with the existing frequency of 50 Hz. And because of that, lot of power was having a reverse transformation. So once upon a time in Vanapur also we faced this problem, when the turbine became like a huge kind of motor, and instead of producing power, the turbine started consuming power. This is called motorization of a steam turbine. This has happened, and it went on for 2 hours. So those who are from electrical domain, they can understand that this kind of problems are not very easy to solve. That was in night time. So nobody understood how this happened. So entire grid it has consumed, right? Constructionally, if you see from construction point of view, there is no difference between generator and motor. And such a large scale generator of 120 megawatt, right? It becomes a 120 megawatt motor, and it starts taking power from the grid instead of supplying. It's a very typical issue, complex issue to solve, right? So this kind of issues, when they are taking place, outage management is very essential. You should have a very efficient outage management strategies, not only formed but implemented, tested, validated by pilots, right? Then only you can isolate that problem into small area, which is called islanding, and the remaining area can continue working. Otherwise, entire state will have this problem, right? And if that happens, the entire state grid will collapse. And how much economic loss if one plant stops for working? I was working with ATAL Limited decades ago, right? At that point of time, I am talking about the time of 1997, 98. If the plant stops working for 1 hour, the production loss is of the tune of 300 crores. Right? After that, so many years, I hope you can understand the value of the money. So, that kind of economic loss because of power problem, it's very difficult to handle. Many companies like ATAL Limited, Reliance, they have their own power plants. You also have to manage outage management. When they are using their own power plant, they are also having the grid supply from the state electricity board or other service providers. Now, how to match that power? Because everything cannot be produced, right? So some power you are taking from the utility company, some power you are producing in-house by your own power plant. Right? If they are not matching in terms of frequency, then the particular area will have a lot of disturbance, lot of collapsing. And if that spreads into nearby area like Valsad and Navsari and everywhere, you will have a cascade tripping. You cannot stop that. It is so fast. So outage management is a very key area here. It will be taken care. And as I told you, plug-in hybrid electric vehicles, charging and supply wire also. Peak load management in certain period. Now, if you analyze the data, you can understand that in May month, in a particular time when the summer is at peak, right? My power consumption reaches to the peak value. Now, if you are knowing that, you can prepare to address that issue when it is peaking, right? So you can generate your own schedules of raw material supply, fuel supply. You can transfer that part, most of that part, because getting the coal is very costly. You can transfer some of the load smartly on the renewables also, right? And that is how you can shave the peak. It is called peak shaving, right? You can reduce the peak, right? And that is how the grid will have a lot of balancing. Wide area situational awareness, I already told you, that is related to the climatic condition study using wide video surveillance. This is also one of the important things. Huge amount of power theft is taking place. Right, in Gujarat, after Jyotigram, it has reduced drastically. But in many other states, it is still taking place. Theft of power. Meter lagavano nahi. Siddo direct. Right? Now, that comes to us who are genuinely paying the bills. They distribute. Right? In spite of that, there is a lot of losses the electricity companies. So in India, the power producing business, power distribution business is always a problem. They are not making huge profits, right? Because of this kind of problem, power thefts and everything. So if you keep video surveillance, it is a part of smart grid. You don't have to depute anybody, right? Using video surveillance, you can detect the theft and unauthorized use of power. Power is a resource now. Operational telephony. When the field engineers are working, right, and they want to communicate with the command center, central command center, right, if they don't have direct hotline access, right, then many things, even if you are having your mobile phone, company will provide your phone or SIM card, right, but whether the network is supporting or not, your mobile phone company may not be having that much network. See, in the entire Gujarat, we have very good network of almost all companies, right? But if you go to other areas, right, let's say remote rural areas in Rajasthan, in Uttar Pradesh, in Bihar, the telephonic network, the cellular network is also very poor. So if as a part of smart grid, if you provide the connectivity or telephony, right, then it would optimize your operational execution. Overhead transmission line monitoring, right? Distribution, generation, everywhere we are taking care, right? What about the transmission line, their health? So if the transmission lines are very old, they need replacement, they are having a lot of problems, because they are in open, so they will definitely have a lot of weather impacts. So those kind of things are also monitored, transmission line monitoring. And last but not least, asset management. Power plants and all the equipments installed by the power producing companies are your assets. They need to be monitored. Their health is to be monitored. Just like we are monitoring our health by periodic health checkups, right? So asset monitoring of the power producing and distribution system infrastructure is essential. So these 19 applications are envisaged, right? Amongst this, certain applications are implemented in some pilot, right? Certain applications are implemented in some other states pilot, and that is how statewide each state is having one pilot. Uttar Pradesh is having 3 pilots, right? 2 in Kanpur, one is in IIT Kanpur, another is outside Kanpur state. I mean, this state electricity board level. So this is end-to-end communication model. First is power line carrier communication. Different technologies used for communication, where your cellular networks cannot reach, right? To supply the electricity, you must have the electrical network. So on the electrical wires, if you are sending the telephonic information or if you can make a call, right, then it is called power line carrier communication. So power lines are used for communication, like telephone lines. So if you came to know, there is a power line modem also available, just like our Wi-Fi routers. Power line based modems are also available, through which you can supply internet as well. Okay, so wherever it is not feasible to lay out optical fibers, wherever it is not possible to provide mobile towers, right, you can use power line carrier communication. Second is wireless sensor networks. Wireless sensor networks are small nodes, wireless nodes, which are consuming extremely low power. And believe me, they are operating with advanced sleep and sniff functions, right? They are used in difficult terrains like hilly areas, right? Complex areas, and they are supplied with 10 years battery life. Guaranteed 10 years battery life. As a part of this, whenever Zigbee, it is operating on Zigbee protocol, right? So Zigbee is having advanced sleep and sniff functionality. So if routine readings are coming, suppose I am taking a reading of this room, and the temperature is, let's say, 25 degrees centigrade or 30 degrees centigrade. My Zigbee based small node, right? It is measuring the temperature. It is having inbuilt temperature sensor, data, signal conditioner, data acquisition device, and transmitter, Zigbee transmitter. Now it is measuring the temperature 30, 30, 30, 30, 30, 30, 30, 30. After some measurement readings, if they are continuously of the same value, it will go to sleep mode. But in the sleep mode, the sensor keeps on working. The transmitter, which is consuming the maximum power in the entire circuitry, goes to sleep mode. Right? Signal conditioning also takes place, and microprocessor is still live with a very, very low power consumption. As soon as the temperature changes from 30 to 31, or you can say 0.5 degree change or whatever, it wakes up and start taking readings. Okay. Again, after some readings are same, 100 reading, 200 readings are same, it goes to sleep mode, and that is how it is saving lot of power. Right. Similarly, sniff mode. Sniff mode means like a sniffer dog. It keeps on checking the reading values. If large deviations are found among consecutive readings, the sniff mode gets activated and will start sending the alerts to the central control room or the monitoring station that something is taking place here. Suppose the readings are changing like this: 30, 25, 22, 45. Is it possible? No, it is not possible. Right? Something wrong is taking place. That is why such a large fluctuations are observed or deviations are observed in the consecutive reading. Right? So that will be reported. So Zigbee based smart sensors are used as a wireless sensor network. Now when it is using Zigbee, it is very difficult to tap it for unauthorized access. Wi-Fi can be hacked. Large number of people can nowadays easily hack Wi-Fi. Right? Bluetooth, there are some experts available. But Zigbee, it is difficult to hack. I don't say it is not hackable at all. But if you take up any mobile phone, any laptop, Zigbee protocol is not available. Zigbee card is not available. One of the reasons why people have been able to hack Wi-Fi is very widely available everywhere. Even if when we set up our phone or some device as a hotspot, it is connecting the other devices via Wi-Fi, if you have seen, right? So Wi-Fi is so popularly available, and that is why it is easy to hack, right? Zigbee is not available in most of the devices, and that is why the hacking or those kind of unauthorized access, security point of view, it is quite strong and sturdy. In most of the surveillance related to defense applications, right? Zigbee is very popularly used. They use smart dust, right? So 1 mm square size smart wireless sensor network, right, are produced using nanotechnology. Believe me, India is doing this, right? Now they produce this kind of 1 mm square size wireless sensor network, right? And 1 mm square is having solar panel, 1 mm square is having microprocessor, 1 mm square is also encapsulating the sensors, various types of sensors. 1 mm square is also encapsulating a camera to take photographs and small videos, and it is also having its own transmitter, Zigbee based transmitter. Now when this kind of sensors are produced in large huge quantity, right, उसको टोकरे भर के हमारे प्लेन जो है ना वो पूरी मतलब बॉर्डर पे जाके उड़ा के आते हैं, तो दूसरे लोग ये समझते हैं कि ये कुछ कचरा है, प्लेन में से आ रहा है या प्लेन की वजह से आ रहा है. Those smart dust are sitting on the border locations, key locations, and monitoring the enemy movement, taking the real live photographs and reporting back. जैसे वो पूरी वाले मूवी में दिखाया था, it was a drone, but it was of quite big size. ये 1 mm square है sir, this is very small. Even using human eye also you cannot see it, दिखेगा भी नहीं. तो राजस्थान के बॉर्डर पे उड़ा दिया सब, तो लगेगा रेत उड़ रही है, ऐसे ही उड़ती रहती है, right? But it is having lot of capability to carry out surveillance, and this is very popularly used, right, amongst in India, right? And large number of such applications can be developed with the help of students, right? And then उसको फिर नैनो वालों को दे दो, वो लोग उसको छोटा बना देंगे किसी भी चीज़ को, right? पहले बड़ा प्रोटोटाइप बनाओ and then give it to nanotechnology people, they will make it miniaturized, very small, using nanotechnology, and then that can be implemented. Again, it is having its own solar panel. So कहीं पे पैड पे बैठा है, कहीं पे बैठा है, तो धूप की वजह से वो चार्जिंग होता रहता है, काम करता रहता है बस. And whenever they are sending data, because they are also doing a lot of surveillance on the other side, let's say China or Pakistan, right? So they will say that large number of huge frequency of data packets are seen, right? So उनको लगेगा कि ये इंडिया वाले कुछ white noise generate हो रहा है. Those who are communication side, they understand noise signal. It's a noise signal because whenever these packets are sent to the remote monitoring unit, right? First packet is sent on, let's say, 30 Hertz frequency. Second packet will be sent on 85 Hertz frequency. Third packet will be sent on 103 Hertz frequency. Every time it keeps on changing the frequency. अब next packet किस frequency पे आएगा, right? That will be known to only two people, sender and receiver, because it is based on random number generator, and same random number generator is working in both the sender and receiver. Nobody else can understand. So even if they want to tap one particular frequency using their communication thing, right, the other packets they cannot grab and interpret. तो उनको लगेगा ये बहुत सारा noise ही generate हो रहा है, right? It is not noise, it is an intelligent surveillance. Same kind of monitoring you can also implement amongst the city areas to monitor the power quality and other things, weather conditions particularly in the hilly areas. IoT based communications where LoRa or narrowband IoT or Zigbee can be used for real time monitoring. Now here the factors of selection, which particular technology is to be used, that depends upon speed. In certain situations like outage management, right, or demand side management, demand response, live demand response, we want speed, right? So accordingly we have to use a particular kind of sensor, reliability and cost effectiveness. certain thing like fiber optic cable is too costly, correct? So cost is also a key area. For the scalability, can we extend the reach? Right, scalability is also a solution, important factor. And then it should be IoT compatible and 5G enabled solution. One of the important factor is latency, because most of the time you might have seen that Wi-Fi network drops when we are working at a peak of our functional aspect, right? Those who are doing a lot of gaming, उनको पता होगा, right? I have been a participant in an inter-IIT Counter-Strike contest. So those who have been extensively gaming, right, they understand that gaming involves a lot of computational power, strictly from engineering point of view, as well as communication speed of communication. अगर आपका communication speed ठीक नहीं है, तो सामने वाला आपको मार देगा game में, right? तो computational power, your own speed with combined with the communication speed is required. Now whenever you are playing the same game on Ethernet, wired LAN we call it, right, the speed is tremendously high, right? But whenever the same game is played, it is a multiplayer game, right? तो मैं यहाँ से खेल रहा हूँ, somebody is playing from Surat, somebody is playing from Ahmedabad, multiplayer game from multi-city. अगर आपने नहीं खेला है तो I must say आपको एक बार खेलना चाहिए. It's a good experience, right? So this is also one of the way to get yourself upgraded, right? That too with students. So whenever you are playing with a poor network, communication network, right, then your chances of failure is very high. This is called latency, right? So low latency network should be provided. Otherwise, the applications among the smart grid will be very, very compromised. Now AI can help you. IoTs, we have seen many applications, right, where microprocessors can do wonders. Right, AI can help you here in data analytics. Particularly to understand the problem and to provide a solution, we have to learn its characteristic behavior and its periodicity. Right? For example, whenever there is a winter, I face cough and cold. Whenever there is monsoon, I face cough and cold. So cough and cold is a problem, right? But when it happens, right, that shows its periodicity. In summer I don't face cough and cold, but there are some people who typically have this problem particularly in summer only. That is possible, right? So that is called characteristic behavior of a problem. For example, suppose whenever I eat pakoda, bhajia, right, I get a gastric problem. So that is my characteristic of my body. And somebody else is eating that, he does not have a problem because his body is able to digest that. Okay, so to understand the problem and its characteristic behavior, its impacts or symptoms are necessary to provide it a solution. Along with that, periodicity, ये कब होता है और कब नहीं होता. That means in some situation when I am eating pakoda, I develop that problem. In some other situation when I eat the same pakoda, I don't have a problem. Right? This is called allergy. So we have to understand that pakoda is same, the body is also same, but situation is different. So in which situation the problem happens and which situation the problem is not faced. Right? That if we know, then we can understand the characteristic behavior of the problem. Once we know that, the solution can be quickly provided. Right? And that can be helped by AI-based data analytics. We have to collect large amount of data of the same problem. It's happening with time stamping and other impacting or influencing parameters. For example, इस particular situation में मुझे हमेशा heart का problem होता है, right? घबराहट है, श्वास फूल जाता है, ये होता है, वो होता है, कब होता है, right? So in peak summer, okay, in peak monsoon, okay, in peak winter, okay. So that periodicity we have to find out, and in which situation it happens. If we find out that thing which is a root cause of the problem using AI, right, then problem can be solved. Because problem is just a symptom, right? Actual problem lies in the root cause. अगर वो solve कर दिया तो हो जाएगा, right? Then using AI we can classify the problem also. There are many similar looking problems, right? For example, if somebody is having, if I am having COVID, then also I will have fever. If I am having typhoid, then also I am having fever. If I am having malaria, then also I am having fever. If I am having, let's say, influenza or flu or that kind of thing, then also I am. So fever is not a disease. Fever is a symptom. Right? Now, if I take same medicine in all the cases, that will not work. So many times the problem is not actually a problem, it is a symptom. The problem is different. Right? Using AI, we can classify the problem and we can understand what is the root cause of the problem. That is applicable to power plant also, or power distribution also, grid also. Many times the grid fails into certain situations which are similar looking. Right? For example, मोटेरा में मैच हो गया तो नरोडा में पावर कट हो गया, या तो फिर मोटेरा के अराउंड पावर कट हो गया. ओके, दैट मींस द प्रॉब्लम इज इन द मैच. फाइन. अभी मैच नहीं है तो भी पावर कट हो गया. दैट मींस प्रॉब्लम इज नॉट विद द मैच. Stadium is not responsible for that particular power failure or network failure. It is something else. Suppose you say that बारिश हो गई इस particular area में, heavy rain, that has caused the power problem. Okay, अभी कहाँ बारिश है, फिर भी हो गया. That means rain is not responsible. It is something else. So classification of the problem is very important in providing the solution during the diagnostic, and that can be developed using case studies. In European countries, they have taken large number of initiatives in smart grid, but in India, under the Indian Smart Grid Mission, Smart City Mission आपने सुना होगा. Smart Grid Mission is a very popular mission. Indian Smart Grid Mission, National Smart Grid Mission, NSM, that is implemented using Power Grid, and it is under the Government of India, Department of Power, which takes place the automation projects of grid modernization and smart grid solutions. They implement the AMI in different cities, right? See, whenever you will implement new technology, new concept, new thing, anything which is new, right? The existing setup will always resist. You might aware about Vadodara, right? Smart meters are deployed. There are problems, right? See, technology, whenever you implement new, right, it will definitely have a problem, right? During my grandfather's time, right, it was a crime, believe me, it was a crime to go to hotel for taking food. बाहर का खाना खा नहीं सकते आप, right? They used to fire me or my father. तुम बाहर जाओ, शर्म नहीं होगी? Right? Now, if they are still live, some of them, right, and if they see Zomato, so adaptability, if you don't have adaptability to novel solutions, you cannot survive. अगर कोई मतलब पुराना आपके पेरेंट्स में या ग्रैंड पेरेंट्स में कोई है एकदम उस टाइप का, तो वो लोग जब यात्रा पे जाते थे ना, तो सारा रसोई का सामान साथ लेके जाते थे, राइट? सब कुछ, जहाँ पे भी जाएंगे, बद्रीनाथ जाएंगे, वहाँ पे पकाएंगे, खुद पकाएंगे फिर खाएंगे. बाहर होटल में नहीं खाते थे, राइट? अभी तो जा नहीं सकते. ऐसे लेकर के कौन जाएगा? पीपल विल क्रैक जोक ऑन यू. हम प्राइमस गाड़ो, स्टव गाड़ो, ये गाड़ो, डबला बबला गाड़ो, पीपल विल क्रैक जोक्स ऑन यू, राइट? सो whenever a new novelty will be there, the adaptability will be always raising the issues. Always there are concerns, and the concerns are genuine. As far as Vadodara incidents are concerned, the concerns are very genuine. But we have to solve those concerns. See, अगर करना तो है, इसका मतलब ये नहीं करना नहीं है, roll back कर देना, बिल्कुल नहीं. For example, in my area, satellite in Ahmedabad, the government is installing water supply meters. लोग ऐसे ही खुले छूट देते हैं, right? So water is a very costly resource. Somebody has told that अगर थर्ड वर्ल्ड वॉर होगा तो पानी के लिए होगा. At that much costly resource, water is becoming. So whenever we implement a novel technology, it will definitely need a lot of adaptation from the, and that is where the consumer's participation is necessary, right? It should have interoperability. This is also one of the key question, right? The best example is Apple. You have Apple phone, Apple to Apple, always problem. I mean, no problem. But Apple to other, always a problem. સફરજન તમે લઈ આવ્યા ને તો તમે પછી એને કેળા સાથે ઇન્ટિગ્રેટ ના કરી શકો, તમે ચીકુ સાથે ઇન્ટિગ્રેટ ના કરી શકો. નો, તમારે બધા સફરજન જ લેવા પડે. If you are buying Apple iPhone, you have to take Apple Mac, right? That means no openness, no interoperability of the device. That happens to electrical this thing also. Those who are instrument engineers, they can understand that Honeywell PLC doesn't integrate with Yokogawa DCS, right? Or Emerson DCS. DCS is a control room computer control system, right? Now that creates vendor dependency. If you are buying a system like DCS, it involves a lot of crores of rupees. So if you are buying the PLC of few lakh rupees, right? If you are buying from the same company, same DCS also from the same company, right? You are creating a vendor dependency. Now suppose there is a failure in some of the hardware or a software issue, right? You have to pay whatever that company asks. So there is a vendor dependency. There is no openness in the solution. There is no interoperability. Because of that, a lot of economic issues related to budgets are also arising. A lot of operational issues also arising. A lot of data security is also a problem. When you are collecting the data of large number of consumers and producers, its security is also important. Like Aadhaar data. This data is also very, very crucial. Consumer engagement. So, in this couple of tables I have provided the communication requirements for the smart grid, which you can take from the coordinators. And what is the reference values, which are the required values, and what are the selected values among this range, right? Where it will work optimally, that I have provided in every application. All the 19 applications I have provided. 11 wireless communication technologies. This is about my research work, which I have validated on this, right? And all over India, all the pilots we have tested on all these wireless technologies, we got interesting results documented. In important areas where the access is limited, in hilly areas like Uttarakhand, like Himachal, like Ladakh, right? We can use satellite LEO, low Earth orbit type technology also. Zigbee, all the three frequencies I have covered. Wi-Fi, WiMAX. WiMAX is not available in India, but it is going to be, right? That is why I have covered WiMAX as well. Cellular, all spectrum I have tried to cover: GSM, GPRS, UMTS, and LTE, 3G, 4G, right? When this research was conducted, 5G was not implemented. Even today also it is not fully implemented. So I have not taken that into consideration. These are some of the publications, selected publications, as far as my research work is concerned. Some high quality journal papers I have published on this. The international as well as national journals. Most of them would be HCBL. Some good quality conference also proceedings I have authored, and one of the conference paper in Springer conference organized by NIT Jamshedpur, I got this best paper award as well. I have intentionally created this presentation with links, so those who are interested, they can click the links and download the papers and read it. Book chapters also we have drafted and contributed in Springer and IGA Global. This last one was with LCWare as well. Some articles I have contributed in international bulletins. Right? Technical reports I have prepared. This first report was submitted to National Smart Grid Mission, Ministry of Power, Government of India in 2019. It is still there on their website. This was submitted to Germany, which is the parent body of PDPU. Now, in the end of the presentation, we should identify the key challenges and issues and what could be the potential solutions. First is the cyber security risk. In India, as if now, we have not faced those kind of issues, but wherever the smart grids have been implemented, these issues have been faced. For example, in US, you can get a threat from somebody, some unknown, that you transfer me this many bitcoins in so and so account. Otherwise, entire New York will not have power, and they can switch off. Right? That is called hacking. Right? Those kind of threats. So cyber threats are also one of the key problems or challenge faced. Right? We have to provide the solution of that potentially using secure communication protocols and encryption technology. Second problem is interoperability issue, which I have already discussed, supplier dependency or vendor dependency. That can be addressed by standardization of various products or accessories you are using. Secondly, third is infrastructure constraints, high cost of implementation and maintenance. This is expensive technology, right? So we have to develop low cost solutions, preferably under Make in India and SSIP, where they can help. Right? So government policies and regulatory frameworks have been already quite helpful, and some future trends that I have identified, that is AI driven grid automation. Right? So AI will be deciding factor instead of, as if now in this present design we have the human beings who are taking the decision while sitting in the smart grid command and control center. But in foreign countries, they also use AI to take decision, right, or decision making process. Now, how much to use, how much not to use, that is always a highly debatable area. But this is possible. Then edge computing for faster data processing, that can also be helpful, like NVIDIA chips. We can use 5G networks for ultra low latency or high speed communication with huge data rates, and self-healing grid with AI ML models. The expected impact of this would be improved efficiency, resilience, and sustainability. Right? So you are never doubtful that I will turn on the switch and power may be there, may not be there. Number one. Number two, high quality power will be available to all. Electrical energy to all. Right? Right from the poorest person in the world to the richest person in the world or in India. Right? And sustainability, that means high quality power is available. It will remain till your requirement is there. That is the thing. So the key takeaways are examined in this particular research work which we have started almost a decade back. Right? We have identified important key takeaways. That is smart grid telemetry and the modern energy management are quite interacting parameters. They are like two sides of one coin. They can coexist, but without each other they cannot exist. Second one is we have identified or studied real world problems. So this is not a purely theoretical concept which I have described to you in this session. It is a practical concept. It is taking place in implementation in real world situations, and that can be used for load forecasting, fault detection, and grid stability management, which are today very, very complex issues. Right? If we don't address them, right, the production quality of factories, right, even if we go for industry 4.0, 5.0, that will be of no use if you don't have a reliable, sustainable, high quality power. Right? It is growing its importance. So the final thought is we can pave the way for green, sustainable, and effective Indian smart grid. That is the conclusion. Right? So those who are interested, I have already given my contact details to the coordinators. I take this opportunity to thank the coordinators, Dr. Ravi Shirpala, Dr. Chirag Nayak, and entire team at the institute for providing me this opportunity to share my views. Right? It is not an expert lecture I am repeating. It is just sharing of whatever I have learned through my study. Right? the support and cooperation from the entire staff and office bearer of this institute, as well as from my parent institute DDU, is thankfully acknowledged, and financial and other relevant cooperation provided by AICTE ATAL is also thankfully acknowledged. And finally, thank you all learned participants for your patience. Still, I request if there is any question, I would welcome. I understand.